Hello everyone. In this video, let's discuss about the how to find a feedback of a op-amp. Okay, so here we can say that this is the op-amp which is connected both for inverting input and non-inverting input with a resistors like this. To find whether which type of feedback it is having, first we need to follow few things. So the thing is, first, voltage source. Okay, so voltage source should be replaced with short circuit, and current source should be replaced with open circuit. So this is the first thing. And you can break any node of the op amp, because you op amp has three nodes here. One is inverting input, one more is non-inverting input, and one is output. You can break any node and check what is it is taking at each particular node. For example, this is v minus, this is v plus. So we need to find what which is dominating, whether v minus, so inverting input voltage is dominating, or non-inverting input voltage is dominating. Based on that one, we can say. For my simplicity, I generally break output node. Okay, let's assume that I have uh, break in here. Okay, let's assume you have v naught voltage, and you need to so if I redraw the circuit again, first let me redraw the circuit again. So if I redraw the circuit, uh, I have this one, and this is minus, this is plus, and I have this, and this is v naught, and I need to replace voltage source with short circuit. So I am replacing, this is short circuit, and current source with open circuit. Okay, this is open circuit, and this is v minus, this is v plus. And here, output voltage, output node, uh, I have broke the output voltage. So let's see what is the voltage at v minus. So first we need to find voltage at v minus. So because v minus, how do how I am finding? Let's assume I am applying a v naught voltage at this node. After breaking, let's assume I am applying some voltage, some v naught voltage at this node, and see what is the voltage at inverting input and non-inverting input. Okay, if I apply a v naught voltage at this node and see what is the v minus. So this is r, and this is r, and this is also r, this is also r. So this is like simple voltage divider. So v naught will be, v minus will be v naught by 2, because here, uh, if I see the total, this is a voltage division rule. If I apply, because these two are same resistors, the voltage across v minus with respect to ground, we should always measure v minus with respect to ground. V minus with respect to ground is v naught divided by 2, and v plus with respect to ground, we need to find with respect to ground here, because there is no current flowing here. Current is I equal to 0, because this is a open node. So v plus is equal to v naught. Okay, and because v plus is greater than v minus here, this is a positive positive feedback circuit. Okay, so this is a positive feedback circuit. Let me revise again. So first, replace voltage source with short circuit, current source with open circuit, and break output node and apply some voltage at this node. Here I am applying some v naught voltage, and check what is the voltage inverting input and non-inverting input of the op amp. So for example, if the inverting input of the op amp is higher than the non-inverting input, then it will become negative feedback. And here we got v plus is greater than v minus, so it is a positive feedback. Okay, so let's consider one more example. Now let's see what is the feedback of this circuit. Here I have replaced this current source with voltage source, and this is v2, and here this is v1, and I have replaced with, previously this was r, and now it is 2r. Okay, so now again, let's redraw the circuit in the previous way. So if I redraw the circuit again, this is minus, this is plus, and there is some resistor, and short circuit v1, and there is here one resistor, and short circuit v2, because the voltage sources we need to short circuit, and current sources we need to open circuit, and this is v out. So I have, I opened this terminal, so I broke this terminal, and this is v naught. I'm considering I'm applying a v naught voltage here. this is R, this is 2R, this is R, this is R, and this is V minus, this is V plus, this is V plus, and this is V minus. Okay, let's consider what is the V minus now. So V minus is equal to V naught into 2R divided by 3R. This is RR get cancelled, 2 V naught by 3 volts at V minus. In the same way, V plus equal to V naught by 2. So here we can say that V minus is greater than V plus. So this is a negative feedback system. So this is a negative feedback system. Okay, let's change a small thing here. So instead of here 2R, let's assume I have replaced 2R with R. Then what is the feedback of the system? Then what it will become? So V minus. So if I short circuit this guy and this short circuit this guy, and if I open here and if I apply V naught voltage at this terminal, V naught apply V naught voltage here, so V minus will be V naught by 2. In the same way, V plus will be V naught by 2, and V minus equal to V plus. That means there is no feedback to the system. So this is no feedback. Now what will be the output voltage? So there is no feedback here. Then the circuit will act as a simple comparator. That means V naught will always equal to A into V plus minus V minus. That means V non-inverting input minus V inverting input voltage. So this will be output voltage. This will be simple, act as a this op amp. This circuit will act as a comparator if I replace here 2R with R. Now let's see one more example. So in this example, simply I shorted non-inverting terminal to ground, and inverting terminal I have applied some V voltage and R, and there is a current source here in feedback, and there is a resistor. So you can say that so many people say that because I am getting only some V naught voltage to only inverting input, then I can say this is a negative feedback, which is incorrect. Okay, let's find what is the feedback of the system now. Let's redraw. So whatever you get the circuit, right, first you should always analyze from the basics. So what is the basic here? Whatever you have voltage source, replace with a short circuit. Voltage source I have replaced with short circuit, and current source replace with open circuit. Then here I have open circuit, and there is a R, there is a R. Then then break the circuit here. That means let's assume I have broke the circuit at the output, and I applied a voltage of V naught at the output. Then what is the voltage you are seeing at V minus? 0 volt. And what is the volt? So let's see, V minus, what you are seeing, 0 volt. What is the voltage at V plus? 0 volt. How I am telling this is a 0 volt? Because it's already shorted to ground. So that means even if you have a resistor here, that doesn't matter, because there is a no current is flowing through this resistor. So here V minus will be 0 volt, and V plus is anyway it's shorted to ground, so this is also 0 volt. That means V minus is equal to V plus equal to 0 volt. So there is no feedback to this system, that is no feedback. So this is the final answer. If there is no feedback, how it will act? So this will simply act as a comparator. That means V naught is equal to A into V uh, inverting input minus V non-inverting input voltage. This will be the equation. Let's assume that means it will always act as a comparator. Okay, if I have a to infinity, okay, let's assume open loop gain is equal to infinity, then V naught is always either plus or minus V sat. Let's assume you have a V input as a positive voltage. That means if I apply a 1 volt, let's assume I have here V equal to, let's assume 1 volt, then V naught will be plus V sat. Sorry. So at output voltage, let's assume if I apply a 1 volt here, then what it will be? So A into V plus is equal to 0 volt minus V minus is equal to 1 volt. That means minus V sat. Okay, so if I apply a positive voltage here, I will see output as a minus V sat. If I apply a minus 1 volt, then output will be plus V sat. Okay, so that's how this will work.